Hello everyone. So today I wanted to talk to you about this book, Zero: The Biography of a Dangerous Idea by Charles Seife. I'm not sure about his pronunciation, so forgive me. But this is a small book, roughly 200 pages, and this is a paperback edition. So, what is this book about? This is a non-fiction book, and basically about maths and science, specifically maths, and why the author is calling this number, this zero. It's both a number and a concept, a very dangerous idea. So I'll just show you the index, and yeah. So here I like how he starts with chapter 0, null and void. So basically, this book is all, as it says, it's a biography. So it's all about the concept zero and the number zero and how it started being used in maths as a number. It was already in use as a placeholder, I think, and but how to use it in calculations and so on and so forth. So how its use evolved since the ancient times, and the number itself, comes the origin of zero itself comes from India, and roughly 1500 years ago, and then it got incorporated into the Hindu Arabic numerals that we all use, this 1 2 3 4 5 6 7 8, so 0 to 9. And and then how that number system basically traveled to Europe, and Fibonacci, the one that you might have studied, of the Fibonacci series fame, that one, then you basically just keep adding the previous number and you get a series which is the Fibonacci series. So this gentleman discovered it, and he quickly understood the utility of it in accounting as well as in maths. And then that's how it got to Europe, and then how the scientific revolution came, and how what was the use of zero in calculus by Newton and Leibniz. And then finally we come to the physics of zero, and then how Einstein's space-time visualization, and what role does zero play there, and finally at even in contemporary physics, what the role of zero is in quantum physics, and maybe even string theory. So that's the scope of this book. So from chapter 0 to chapter infinity, and specifically I like this because in this infinity's twin, the infinite nature of zero. So he basically, I think it's a very apt description of defining zero as a infinity's twin, because both these were concepts from India, and these were philosophical ideas. If some of you might be aware about the shunyata concept of Buddhism, that basically inherently it's a philosophical concept that there is nothing really in pure existence. Basically it comes from nothing. So, and how basically these philosophical ideas of zero and infinity, you must have heard in maths that infinity is not a number, it's a concept. It just denotes something that is beyond what is finite. So similarly, zero was used as a concept. It was never used as a number. So here you can see nothing comes of nothing, and this type of idea that something can come out of nothing, it was really very strange, philosophically speaking, from the Greek philosophers. And so the West rejects the zero initially, right? And then the theology of zero, here the author discusses the basically how zero made its way into theology or religions, and the infinite God of nothing, and a bit of Hindu philosophy of Advait, Vedanta, and Buddhism. So these were concepts already in India, but to use them in specifically maths, and for the betterment of the material world, how it got applied to the scientific revolution, that's the main contribution of the West to actually use zero, because the Indians and the Eastern religions basically focused on the subject, on the mind, and its suffering, and how to end its suffering. And so to basically see this world as, illusions or nothing or zero. So that concept is already there. The shunyata concept was already there in Buddhism from some 2000 years ago. But how to use it in maths, and specifically for multiplication. In the initial chapters, the author discusses how in the Roman numerals, that I, double I that we use, 1, 2, 3, 4, there is no zero, and it's very hard to add or multiply numbers, especially when the numbers are large. So it's very troublesome. So this Hindu Arabic numeral system basically just changed the whole picture. And this objective minded viewpoint of the West, it basically boosted the scientific revolution. And just some the book is very beautifully illustrated also, and various examples are given. So even if you are not someone in expert in maths, you will I think understand some 80-90% of it. So the best part that I thought was this one, the infinite nature of zero. And this infinite series, if you see, it's something I like to give elementary kids to just mess with their minds. That I give them the series 1 minus 1 plus 1 minus 1, and then I tell them what would be the answer. So some would say 0, but then I would say that what happens if you group these 1 and minus 1 like this, then the answer will be 1. So what is the final answer? And obviously this is very some advanced convergent divergent series stuff, but kids don't know that, so I like to mess with that. But anyway, so that concept is covered here. Then there is this integration stuff, that if you think about it, if you have studied integration in maths, it's basically to find the area under the curve. You basically assume small rectangles of infinitesimally small width, and then you add them up. But this whole concept of infinitesimal, it's very, very, very counterintuitive. We don't really think about this stuff when we were in a school or college, and we just use this concept blatantly. But it's very counterintuitive, and that's what the author has mentioned here. That see, from the starting here, Zeno's paradox, I think most of you must be aware of this. So this argument of this infinitesimal and zero, these were always there, but how they impacted our real world applications, this is beautifully described here. And let me just I was going to show you, yes, this one. This is the integration stuff that we used, and this Kepler's volume measurements of barrels. So in integration, it's a common technique that if you want to calculate the volume of a cylinder, so you assume that the cylinder is made up of some infinite number of discs of almost zero thickness. So if you stack a lot of circular discs, you get a cylinder. And if each thickness goes to 0, as delta x goes to 0, so you get the volume of the object. But this Kepler ignored the problem, though adding infinite zeros together was gibberish. From a logical point of view, the answer was obviously the correct one. And this was something that also bothered me when I first started reading calculus in school, that it doesn't make much sense. How can you just add up infinitesimally small widths to get a volume? It's really counterintuitive. But then again, the whole geometry also works on that concept only, that a point, it's very difficult to these axioms that we take for granted. Once you start to ruminate on these things, I think this comes under philosophy of mathematics subject. What is a point? What is a line? The basic assumption of a point is very one-dimensional unit. But what does it mean? I mean, it's an assumption, a helpful assumption. It got us to the moon and whatnot. But if you start thinking about these things, especially this stuff, calculus, and the applications of calculus then to the physics, obviously, then motion of things, without the concept of zero, it would have been impossible. So here also these calculating the roots and to find the slope of points, tangents, areas and curves. And finally, this also is quite popular when we study maths, L'Hopital's rule. In India, I know many students, including me, we called it El Hospital rule, which is completely wrong. But yeah, to differentiate some algebraic equations quickly. So it was a shortcut if the answer was of zero by zero form. So maths students will know this, but this doesn't solve the problem. It's very very paradoxical, I think, the whole calculus and integration stuff. Or maybe I think that is, I don't know if mathematicians are very clear on this, that it's no paradox, but that's the sense that I got from this book, that it's a very beautiful idea, but also very dangerous if one starts to think about it. And it's also made me think about how much of our present world is built upon such fragile, or fragile assumptions, you can say. You can think of the banking system also, how money is created. And yeah, if many people knew how money was created, so I personally think it's a very fragile, it's not built on very solid foundations, I think, personally. It's an idea and it works well, and that's all it takes for such a whole system to work, banking, financial system. Similarly, the scientific applications like satellite, or even a building a rocket, going to the moon, semiconductors, all these concepts use zero in their calculations, and they work perfectly fine. But the basis of it, this idea, it's basically just an idea, an approximation of reality. That's what maths is basically, right? In maths we can say very easily 1 equal to 1, but in a practical world, there is rarely anything which is identical to each other. Nothing is identical. I don't think even two atoms are perfectly identical at the quantum level also. I'm not sure if any physics expert can correct me on this, but okay, not even if they are identical at the quantum level, not at the macro level, they can never be two identical objects, each atom, each electron in the same place. It's simply not possible. So 1 equal to 1, if I keep two apples here, I say I give you one apple, then another apple, and you can say that I've given you two apples. But in maths we would say 1 plus 1 equal to 2, but again those two apples will never be identical. So 1 plus 1 is it's basically an idea, it's an approximation, an abstraction of reality. That's what maths is. And zero is a very beautiful but a very dangerous idea also. So that's what is covered in this book. So please read it and share it and discuss it. And thank you. Happy reading.